Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Scaling Applications. Scaling applications is a critical aspect of performance tuning in cloud environments, forming a cornerstone of mastering CompTIA Cloud Plus. At its core, scaling involves adjusting the computational resources allocated to an application to meet changing demands. This can be achieved through vertical scaling or horizontal scaling. Vertical scaling increases the power of existing resources, such as upgrading to a more powerful CPU or adding more RAM. In contrast, horizontal scaling involves adding more instances of resources, such as additional servers or virtual machines, to distribute the load. The significance of scaling applications becomes apparent when we consider the dynamic nature of cloud computing workloads. Cloud applications often experience fluctuating demand, with periods of high traffic interspersed with low usage. For instance, e-commerce platforms typically see spikes in traffic during holiday seasons, requiring a robust scaling strategy to maintain performance and availability. Failure to scale effectively can lead to performance bottlenecks, while degraded user experience and potential revenue loss. Horizontal scaling is particularly advantageous for cloud-native applications designed with microservices architecture. Microservices break down applications into smaller, independently deployable services, each responsible for a specific functionality. This modular approach allows individual microservices to be scaled independently based on their specific load, leading to more efficient resource utilization. For example, an online video streaming service might need to scale its video encoding microservice during periods of high content upload, while its user authentication microservice might require scaling during peak viewing hours. This granularity in scaling helps optimize performance and cost efficiency. Cloud providers offer various scaling mechanisms to facilitate both vertical and horizontal scaling. Autoscaling is a prominent feature that automatically adjusts the number of running instances based on predefined policies. These policies can be configured to trigger scaling actions based on metrics such as CPU utilization, memory usage, or request count. Autoscaling ensures that applications remain responsive under varying loads without manual intervention, enhancing operational efficiency. Moreover, it helps in maintaining cost-effectiveness by scaling down resources during periods of low demand, thereby reducing operational costs. Another critical aspect of scaling applications is load balancing. Load balancers distribute incoming traffic across multiple instances to ensure no single instance becomes overwhelmed. This not only improves application performance, but also enhances fault tolerance by rerouting traffic from failed instances to healthy ones. Various load balancing algorithms, such as round-robin, least connections, and IP hash, can be employed based on the application's requirements. For example, a web application with a high number of persistent connections might benefit from a least connections algorithm, which directs traffic to the instance with the fewest active connections, ensuring an even distribution of load. To illustrate the practical implementation of scaling, consider a case study involving a social media platform experiencing exponential growth. Initially, the platform's architecture comprised a monolithic application running on a single virtual machine. As user numbers surged, the application suffered frequent downtimes and slow response times due to resource exhaustion. The engineering team decided to refactor the application into microservices and deploy it on a cloud infrastructure with auto-scaling and load balancing. The migration involved breaking down the monolithic application into microservices for user management, content delivery, messaging, and notifications. Each microservice was deployed in a containerized environment using Kubernetes, which provided robust orchestration capabilities. Auto-scaling policies were configured to scale individual microservices based on specific metrics, such as the number of active users or the volume of content uploads. Additionally, a load balancer was implemented to distribute incoming requests evenly across the microservices. This transformation resulted in improved application performance, reduced downtimes, and enhanced user experience, demonstrating the efficacy of a well-planned scaling strategy. However, scaling applications is not without challenges. One of the primary challenges is ensuring data consistency across scaled instances. In a horizontally scaled environment, multiple instances may concurrently access and update shared data, leading to potential conflicts and inconsistencies. Techniques such as distributed transactions, eventual consistency models, and conflict resolution strategies are employed to address these issues. For example, a distributed database like Amazon DynamoDB uses a combination of eventual consistency and conflict resolution to ensure data integrity across its distributed nodes. Another challenge is managing stateful applications that maintain session information. Unlike stateless applications, which do not retain client context between requests, stateful applications store session data, making horizontal scaling more complex. Techniques such as session affinity and distributed caching are used to manage stateful applications. Session affinity ensures that a user's requests are consistently routed to the same instance, preserving session state. Distributed caching solutions like Redis or Memcached store session data in a centralized cache, accessible by all instances, thereby enabling horizontal scaling of stateful applications. Monitoring and observability are crucial components of scaling applications. Effective monitoring involves tracking key performance indicators such as response time, throughput, error rates, and resource utilization. Tools like Prometheus, Grafana, and CloudWatch provide real-time insights into application performance and help identify scaling needs. Observability extends beyond monitoring by providing a comprehensive view of the application's internal state through logs, metrics, and traces. This holistic approach enables proactive identification and resolution of performance bottlenecks, ensuring optimal scaling. Security considerations also play a vital role in scaling applications. As the number of instances increases, so does the attack surface, necessitating robust security measures. Implementing network security controls, such as firewalls and intrusion detection systems, helps protect scaled instances from external threats. Additionally, ensuring secure communication between instances through encryption and employing access control mechanisms are essential to safeguard sensitive data and maintain compliance with regulatory standards. In conclusion, scaling applications is pivotal for maintaining performance and availability in cloud environments. Both vertical and horizontal scaling offer distinct advantages, with horizontal scaling being particularly suited for cloud-native applications with microservices architecture. Auto-scaling and load balancing are essential mechanisms that facilitate dynamic resource adjustment and traffic distribution, ensuring responsive and resilient applications. Despite the challenges associated with data consistency, stateful applications, and security, effective scaling strategies, augmented by monitoring and observability, can significantly enhance application performance and user experience. As cloud computing continues to evolve, mastering the intricacies of scaling applications will remain a critical skill for IT professionals, underscoring the importance of this topic in the CompTIA Cloud Plus certification. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.